Hello everyone, this is Surya Teja, and right now we are going to solve the problem code chef reduced to 1, and problem code is Red1. Arun has integer n and his friend likes the number 1, so Arun wants to reduce n to 1. To do so, he can perform the following more solid and possibly 0. Pick two integers x and y such that x plus y is even and x to the power of y is a divisor of n, and then replace n by x power y. Note that each step x y only needs to be divisor of the current value of n and not necessarily divisor of integer Arun initially started with. Find the minimum number of moves Arun needs to n to 1. If it's possible to reduce n to 1, print -1 instead. Okay. So let's analyze the question. They are given the values of n from 1 less than to 10 to the power of 18, and if they are given n and you have to divide with some x to the power of y, and you have to make this equal to 1. So this, it is quite simple. You can understand it is if you divide n by x to the power, so if n mod x to the power of y equal to 1, then this is the answer. So let's see the sample test cases. So 25, 24. If you take 25, 24, if you divide 25 divided by something x to the power, it gives to 1. So if 25 is odd number, right, and if you divide 25 by 25 equal to 1, and you have to check another also, x plus y equal to even. If n is odd, then odd to the power of 1, so odd plus 1 is equal to even. So if they're given n, if n is odd, then it simply equal to 1, and then 50% of cases are done. Then you have to see remaining 50% of the numbers, that is even numbers. And the best way to, if you have even number, then try this even number to make odd, and in one operation you can do the odd into one way, into equal to 1. And if doing so, if you take this even, and if you trying to make that even into odd, it take one way, and from odd to 1 it take another way. But in some cases it will give, you don't have to think suppose 3 possible ways or 4 possible way, 5 possible way. You don't have to, because if you can do in one way, then one is best. Like if you know your order are completed, then you have to do with even. In even, if you're trying to make it odd, you can do in, suppose you can divide with 2, you can be able to do, say, 2 power 1, that is odd. But if you get 2 square or 2 power 4 or 2 power 6, you can able to divide it to, suppose take 2 power 6 by 2 power 2 equal 2 power 4, and divide by 2 power 2 equal 2 square, divide by 2 power 2 equal to 1. You can do in 3 ways using this, but our total aim is to minimize the number of operations, so we don't have to see you can understand, like, the maximum is 2 only. Make that odd into even, and even make that even into odd, and that odd into 1. So let's see which of the how the cases are varies. So if you take -1, you can't able to do for which of the following numbers, and 0 and 1 and 2. So let's keep this -1 aside and think about 0. Okay, for if n divided by something equal to 1, so 0 ways you have to do this function. So 0 ways means straightly n equal to 1, so 1 equal to 1, so you can do in 0 ways. So this case is completely over. If you take 1, we have already seen the previous slide, that is, if n is odd, then equal to 1, that's it. But in some cases also, when if you take, suppose, n by x to the power y, if you take n Now if this only case is n is even, if n is even, then that's, if it is a perfect square means n equal to some a square, then suppose if you take n equal to 2 to the power of k into 3 something 3 5 anything, that is 2 to the power k into odd, right? So if you want to take this even number and we have to divide with something even number and we have to make this equal to odd, then it's straightforward. We take only one step and make it 1. If you divide it odd, so we have seen that previously itself. And now we have to decide how we can take that 2 common thing and which how you can divide it and how you can make into odd. So 2 power k. Now the only thing is remaining is this only. In 2 power k also, if you take 2 square 2 cube, means if k is odd or even, the in 2 power k this is odd or even, because in suppose if you take an even number 60 and you can't able to divide 60 because 60 power 1, so x plus y equal to odd, so you can't able to do that. So you have to in 60 suppose take 5 into 3 into 2 square, right? And if you remove this 2 square in one way, because 2 plus 2 equal to 4, that is an a1, then it converts into 5 into 3 15 is odd, so plus 1. You can do in two ways. No, in some cases it will print -1, for which cases means if you take this k equal to odd. No, even means if 2 power k is even, then 2 square into k 2 square into k by 2 is also possible, then it's only one way if k is odd. And suppose you can take 2 power k is odd and 2 power k minus 1 is even, so 2 power k minus 1 into whole square, so it will still be 2 power 1 into that odd values. So you can't able to remove this odd, because you can't able to do it. 2 power 1 means it will be 3, and so it's not possible. So the values in which it will print -1 means it takes suppose 2 power k into some factorization, and if k is odd, then this is the only case in which the answer will be -1. So right now we have understood, and now it's remaining is k is even, 2 power k into some odd. So we can directly divide by 2 power k, so this goes to 1, so equal to odd. The two ways, but you can understand in different way also, like if this odd is a perfect square, suppose this 2 power k into odd into some power like m, then you can able to divide it 2 power k by 2 into odd power m by 2 whole square. So if you take this value, so this is definitely, if you multiply both this, and you will get an even number only. So even plus even is again an even. So if k is even, then we have two cases, that whole number is a perfect square or it's not. If it is a perfect square, then a straight way, it's if you take that root and you can whole square, so that root is equal to x and y equal that root of perfect square and y equal to 2. So this is one way. And we have seen that if it's not a perfect square, then we have to remove that k, and remaining that odd way out, that is same, it's just only one way you can do that odd into even, equal to one way. So means I'm just finalizing what I have told before. -1, 0, 1, 2. -1 means if you take that number and it's an even number, and suppose 2 power k into odd, if k is odd, you can't able to remove this odd. So the answer is -1. If 0, then it's straightforward 1. The number is equal to 1. If 1, we have two cases, like it's an odd odd set minus one number, then it's a perfect square. And 2 means it's just any number, it's a even number with two number of 2 is in even multiples, that is 2 power k, k is even into some odd. So let's see how the code will work. You can see first I have in the test cases, then the number is to the 10 power of 18, so I have to use long int. Then I have temporarily set n1 equal to n. If n equal to 0, then it's straight out, means in my code that is cout of 0 and l, so it will give 0. If it is odd, then it will give odd. Then right now I'm checking right now I'm checking, like if you take the n and PO2 means number of multiples of 2 in that n1 number, that what I am calculating is p of 2 equal to, suppose this number equal to 2 power k into some sort of odd, then in we are calculating this PO2 equal to k, number of 2's in that. So we have taken while loop, and if you can understand, while if this condition only satisfies, then only the loop will run. So for every time if that loop runs, the number of 2 will be counted. So PO2 plus plus means it will PO2 equal to PO2 plus 1, and that number is decreases by and then number we will divide it by 2. So that's why loop will run. If it doesn't have any multiples of 2, then it will break. And if PO2 and 1, so PO2 and 1 means is there's nothing like to divide modular equal to 1, means that PO2 sort we have already discussed, this output is -1 and return. And we are using this binary search right now because if the 10 is less than 10 to the power of sort of 14, 15, then you can straightly use for loop, and if I into I equal to n, then you have break and see what you can easily calculate the value of I, but it's 10 to the power of 18. And for this you have, if you take the square root, that is 10 to the power of 9, so it will give TLE. So this is one procedure, like a binary search, that is it will take O of log n, and many of them to know this binary search, and it's a basic algorithm. And right now I'll explain how it will work. Suppose I have fixed that low equal to, so if you take this line, suppose your answer is this, suppose take root 10, I will set this equal to 1 and high equal to 1 in it. And right now I'm dividing with suppose low equal less than or equal to high, suppose mid equal to low plus high, suppose this will take 10 to the power 9 by 2, and suppose here, so this condition is suppose it now mid is here, now this mid into mid is greater than n, right? So that height will be changes to here, that previous one, And suppose if you take again, the mid will come like 1 into h plus hi, that is suppose here, and this low equal to mid plus 1, and the low will move here. So in every time the binary search means it will come near to the answer, and if answer is satisfied, if greater than or less than only remaining is equal to case. In that case, if it is equal, then we know there's only one output, and we have done with all cases, and remaining is that 2 power k into odd. It is not a perfect square, and only k is even case remaining, that is equal to 2. So that's it. And in this kind of questions, I think no, it's a greedy one. You have to divide the question into a variety of cases, and each cases you can do by this way. Thank you so much.